Cocomelon! No, no, I should not have been this close. Wait, is the gain on the fucking microphone insane or what? No, the gain is fine. It just didn't like it when I said Cocomelon! Alright. Yeah, no, something there seems... I hope that audio is fine. I'm gonna close up some other stuff, maybe. It cannot be on, actually. It cannot be on. I didn't need the exam, though, in front of me somewhere. Is it this one? No, it's not this one. Can I do... Oh, I don't know the date of it. Did I write the date up here? I did. Wait, let me try thing, chat. We're gonna try thing. So if we're at 04/28... Fuck, it didn't work. Oh shit. Go back. Okay. So we got this exam here, which isn't the one we're gonna do. So I'm gonna need to find the one we wanna do. There's a bunch of other... Okay, so here's this thing. So this is the one we're gonna do. Yes, this is the one we wanna do, because this is the one we did on the lecture. And we should be good to go. I'm trying to think if there's a good way of having it on my... Because here is the examinators. Right, you guys only see my screen at the moment. Yeah. So you guys can just stay there for a moment. I just need to get... Oh lord. Here, go back. Here. Okay. Yeah, I just need to find the exam real quick on my iPad. Wait, I have a thing here, I think. This one? Oh, it's a Canvas page. It's not entirely what I want. It's not entirely not what I want either. If we can find the website on here. Course assessment, computer project teachings, schedule, official course syllabi. If we go into here, maybe it... No, that doesn't give us the website. If I type it into Google, Feminine 10 is the name of the website. So here is the course. There's a bunch of courses, FMN 10. It's this one here. There's an internal server error. That's not very helpful. Here, I want the fucking exams, man. Don't take no. God damn it, I just want the fucking exams, bro. Menu. Close tab, damn it, inte det rätta efter. Oh, what the fuck is happening? That just doesn't do anything. Oh chat. Wait! I figured it out. I can send the damn link to myself on here. I'm stupid. I literally have a chat function. Bam. And then we go into here on the iPad. Let him load for a moment. And then we go into the chat. And then there is a link. I'm a genius, chat. I am a goddamn genius. You guys would have never ever done that. Okay, we're gonna add it to the thing here. I mean, maybe you could do other things too, but that is the goal. I can actually move the microphone a little bit closer to me. So I should be able to pretty much sit like this. Let me just go into here for a moment, check out everything looks fine. Yeah, everything looks good. Trying to see here. Cover up there. Right, this one should be. Yeah, this looks fine. This looks fine. Let's go with this. So hopefully this setup sort of works. So we have the old example stuff here, which I can go through if we need be. Otherwise, we didn't do the fourth one on the lecture, but we should be fine. So we got this method here. So the goal here, let's remove this last page here because we don't need it. Oh, it removed the wrong one. I'm stupid. There we go. Page here. Gonna go here. Gonna copy the first question. Yeah, that's the goal. Bim bam boom. Go here. Right, so we have this multi-step method here on the following formula. I'm just going to write it down. So we have yn plus 1 minus alpha divided by 2 yn minus 1/2 yn minus 1 wait, I fucked up. yn minus 1, there we go. Let me actually write it like here, I think, so we can actually write the whole thing as it is. Beta 2 f of yn plus 1 plus beta 1 f of yn plus beta 0 f of yn plus 1. One of those should be a minus. Let me scroll up here to check. I think there's the one in the back, right? Yes, that one should be. Yeah. So, yeah, so it should be this guy here, which is a minus sign. It's just a little typo in there. Easy mistake to make, I suppose. Yeah, so we got this set up here. And we want to check. Determine the value of the parameter a so that the method is consistent. So in order for the method to be consistent, let's write here, in order for the method, to be, oh Lord, to be consistent, we require that I write like this. So alpha divided by 2 minus 1/2 yn here minus 1/2 yn minus 1. We need this to we need to be equal to 0, right? I think that's like to fulfill this equation here, I think, because if we just scroll up the top here, yeah, well, it's gonna mean that eventually. That's what we're gonna end up with, so to speak. Because so like what I'm writing there is correct, but I shouldn't write it like that. I should write it like we should write it like that the method do I just check here. Yeah, I'm in frame and such. Just need to sort of make sure. We need a method. Require that the method fulfills the, can I call it the polynomial test? I don't know what a good name for this would be. The polynomial test equation. For at least, can we call it order 0, right? Yeah, so we check. So in other words, I could copy that. I'm just going to write consistent of order P method is consistent of order P is probably I should write this. Method is consistent of order P method is consistent of order P if it is exact for polynomial. If exact for polynomial of degree less than or equal to P. Yeah. So we can write here where we check with y of t equals t to the power of p. Yeah. Let me write a little red box around this because this is important, or a little purple box maybe. The purple box disappeared. How interesting. How very strange. Because it's there, we can sort of see it, but it feels like it's underneath the thing. I'm curious if I go up here, because here we can see the actual color of it, and then here looks fine. Put two on top of each other. If we then copy them, right? Yeah, it goes underneath, which is really interesting. That's a fun bug. Anyway, Can I get a fucking... Holy shit, we can't get a box. Right, fuck the box. So we're going to check this thing here with f of y, right? Equal to y bis, or y prime I should say, which is p times t p minus 1. Yeah. So I suppose that we should do order 0 here, right? Can we do like this? We can sort of, I still want to see like the thing. We also need to introduce do we need to introduce a grid here? I think we do, right? Yeah. I don't remember how to do another thing. I'm just going to do it like this. Well. I'm going to go yn minus 1 equals, because we had, at 0, we had y0. So I'm going to say yn minus 1 equals like y of 0, which is y0. This then means that yn equals to y0 plus h. Yeah. Sure, that is what this means. And yn plus 1 equals to y. Should I write this like 2h, so to speak, or like n times h, right? N times h, n times h. We can sort of write it like that. Yeah. Yeah. Let's go something like this is how you should do it. So now we insert insert yn of t to the power of p. So we can, I guess we can, first of all, we can write down what this is. Trying to see if this is like a good way of even doing it. Or if I should do like minus h instead. Let's do minus h instead. That guy. Because it's not, it just doesn't look right in my brain. So yn minus 1 here would be minus h for n equals 0, and here we would have y of 0 equals y0. Here we would have plus h, so to speak, right? I'm not sure I'm doing this right here. but yeah, this should then be it. Yeah, just insert this thing into the polynomial. So yn plus h to the power of p minus alpha divided by 2 t to the power of p. Here it should say t. That's what I'm doing wrong. Here it should say t minus h yeah, and here it says, well, we already have defined this. Yn t equals t to the power of p. Right. Now insert the stuff in this thing. Right, yeah, that's what I was doing wrong there. That's like I knew I was doing something wrong. I just couldn't figure out where I was thinking about it wrong. So here it should say yn, it should say th minus alpha t to the power of p minus 1/2 t minus h to the power of p. This shouldn't equal h. Beta 2 f, we know is y prime. So this will be p times t to the power of p minus 1 plus beta. Oh no, wait, this is wrong. I'm trying to see here if I can write it all in one line without it looking like dog shit. Maybe we can't. Maybe we'll write it on here for now. This equals age beta 2 times so instead of t we have th. We could write it in 2 steps. Let me write it in 2 steps. F of t plus h to the power of p plus beta 1 f of t to the power of p plus beta 0 f of t minus h to the power of p. Here, see here if we close down one more here, that should then be this thing. So this thing here should be this thing here, and this thing here is now h beta 2 times p. This p jumps down. The inner derivative is 1. P minus 1 plus beta 1 p times t p minus 1 plus beta 0, which is p times t to the power of minus h p minus 1. And this is the right. So if we now just like write this again, but just to try to keep it small. This isn't how he did it on the lecture, but we should end up at the same result. It's 1/2 t minus h to the power of p should then equal this thing here, which I'm just going to copy over here. smaller so it all fits on one row. A little smaller like this. Okay, now this is the equation, and my iPad is stuck. There we go. We're back. I should probably sit like straight up. I'm like leaning towards the armchair. Yeah. So now it's right here. Now we check for what order this equation system holds. Bam. So now we write P equals 0, which gives us zero here, here, and here. 0, 0, 0. 0, 0, 0. So this thing is then equal to 1 minus alpha divided by 2 minus 1/2 equal to, I'm just going to write it in red there because it's 0, and then this, if I've done it all correctly, this then means that alpha divided by 2 equals 1/2, which means alpha equals 1, which is what we were expecting to get, which we know is correct because I've done this before. Now we do the same thing here. For p equals 1, we go here, write down the system here. I'm thinking if I can, there's like a good way of, I almost want to like add little spots for them. So then I can replace in what's like supposed to be in the place. I don't know if this is like a fucking smart way of doing it. It might not be, but here we have to the power of, let's go green here, so it's 1 less. I think this is, because we're gonna need to put the thing in there anyway. I mean, we could also just not, we cannot color code them, of course. I want to. It will look a little neat like this. Yeah, so now we can copy this thing. Like, just put him here for now and we can go get him later. So then we write 1, 1, 1, 1, 1, 1. 1 minus 1 is 0, 1 minus 1 is 0, 1 minus 1 is 0, oops, 0. This then gives us t plus h, 1/2 t minus 1/2 t minus plus h divided by 2. These guys take out this guy, which which means that this thing here is equals to 3 divided by 2h, which is equals to this thing here, which is h beta 2 plus beta 1 plus beta 0, because all those things are 0. So this is the equation. I think on the, like they have like where they take one minus the other sort of thing. I think it's all fine for now. So you can have the final equation on that form. I think that's fine. P equals 2. We are going to just duplicate this guy. Put him here, put a 2 here, put a 2 here, put a 2 here, put a 2 here, put a 1 there, put a 2 there, put a 2 there, put a 1 there. Yeah, I guess we're gonna need to expand these things out here. So we have 2 plus 2h plus h squared minus 1/2 t squared 1/2 t squared minus 2 th, just say th here, I think, th plus h squared, which can then be written as okay, I'm just gonna write it once more. Th plus h squared is 1/2 t squared minus 1/2, not 1. It is 1/2, it is minus t squared divided by 2 plus 2, oh no, th plus th minus h2 squared. This here is then equals to, because so this thing here and this thing here, those guys go against this thing, so we got th This doesn't look right. Let me check with the guy up here. Right, we have Tn equals 0. That's what we're remembering. For any t, pick t equals 0, right? That makes our equations simpler. They don't cancel out nicely. So then we have 1/2 h squared left, zero t equals 0, t equals 0. I'm just gonna write it out every time, so just, you know. Yeah. And this then equals h times b2 times 2 times h plus b1 times 2 times 2 times 0 minus BO times h times 2 times h 2 times h. This gives us 1/4 equals b2 minus b1 b0. Now I have for p equals 3 t equals 0. I'm just going to write it out again because it's 3 here, 3 here, 3 here, 3 there, 2 there, 2 there. I'm going to use the fact that t is equal to 0. Which is h3 minus 0 minus plus is 1/2 h3. This here is then equal to 3 divided by 2h3. The other side is h 3b beta 2 h squared plus 0 plus 3 beta 0 to the power of 2, so it's h2 here. This then implies here, if we break out the 3's, we kill this 3 with this 3 with this 2. This then gives us 1/2 b2 1/2 equals b2 plus b0, which I think is a violation of something. Or no, I think it's the next one that does that. So let's write down the last one, and here we'll get the contradiction. So here we have 4 t equals 0. We have h4, I should say. No, I didn't. No. I'm just gonna write it like this: h4 minus 0 minus 1/2 h4 equals 1/2 h4 equals h beta 2 times 4 times t0, so it's just h to the power of 3 plus 0. This one here is minus, so it becomes minus 4 times beta 0. 4 times beta 0 times h to the power 3. This simplifies to 1/2 equals, or 1/8, right? 1/8 equals beta 2 minus beta 0, which goes, let's write it in, I want to write it in yellow for whatever reason. This contradicts p equals 2. Yeah. Right. So we get the following equation system. Yeah, we're just gonna copy all the stuff. So I guess we'll need the first one because that one is sort of on its own. We have beta 2 plus beta 1 plus beta 0 equals 3 divided by 2. Is this the same that they got here? No, this is the wrong guy. We need this guy here again. Just want to make sure that I got, yeah, 3 1/4 and a half. Minus there, plus there, plus there. Yeah, so this looks right. So this is the equation here. Following equation system. This is the first equation. This is the second equation. You can put it in matrix form if you want to. We don't need to, but I might. Rearranging. What the fuck happened there? Did my pen die? I think it did. I think it goddamn did, bros. Sheesh, let me check. It is dead, yeah. Not super much time left either. I need to like do some dishes and take out some trash and things. I was gonna go to the gym today, and I might like do something and like get up when I get there, but like I might also not. Really haven't decided. Really haven't decided yet. It's gonna charge it for too long, so I'm not going at it for too long. Let's just see it charge up. That's kind of fun. I'm gonna charge it up a little bit more, but like it doesn't need to charge for very long for it to be like useful for a while. So I think this might be enough. I just want to finish this task. Plus beta 0 here. Do I want to write it in a fucking matrix form? Let's write it on matrix form. If nothing else, just to like, sounds a little silly to like practice writing it in matrix form, right? 0 minus 1, and then 1, 0, 1. No, I've written it a little weirdly, right? Usually I write it 0. We get 2 beta 2 equals, I'm gonna write these guys, 4 divided by 2, I'm actually gonna write this guy as 4 divided by 6. Yes, so they're all on the same basis. This then equals 3 divided by 4. This applies beta 2 is equal to 3/8, which means that beta 2, or no, beta 2, beta 0 is equals to, let's see here, I should write this guy as 12/8. So this guy's then 2. 2/8, 4/8. This guy should then be 1/8. Yeah, 1/8. Which then means that B1 is 4/8, 8/8, 8. 3 minus 1 is 2, yeah, then 8. Yeah, this should be right, which is just 1. What answers did I get? Have I just done this correctly? Right, I mean, this takes no fucking time. Why didn't he do that on the fucking exam? It takes no, like, if you've already gone through all the trouble, yeah. And then we check zero stability too. Yeah, so let's just write answers. Yeah, oh, it's an alpha, right? Alpha equals 1. Beta 0 is 1/8. Beta 1 is 1. And beta 2 is 3. The method is consistent of order p equals 3. So it's consistent of order 2. No, okay, so it is order 3. Yeah. Now we check B. We want to check for 0 stability, which means f equals 0, right? I think just scroll up here like a motherfucker. Wait, no, we don't need to scroll that far. We need to scroll up like this far somewhere. Here. Is the method 0 stable? Which means, is it stable for f equals 0? So we check y and wait, what's the equation again? yn plus 1 alpha we know is 1, so it's 1/2 yn minus 1/2 yn minus 1 equals, well, if f is 0 then that side is 0 in this instance. We can actually write it like h times, let's write it beta 2 times 0 plus beta 1 times 0 plus beta 0 times 0, which is equal to 0, just being extremely explicit on what we're doing. Just to not cause any confusions, right? Because we're not automatically setting the other side to 0. If there were like a constant or something in there, then we would need to handle that, right? But in this instance, it is just f equals 0 leads to the other side being 0. Now we take the characteristic equation. Usually this will be the form, right? It'll almost always be this form, but like, I mean, it doesn't have to, right? Characteristic equation here gives us lambda squared minus 1/2 lambda minus 1/2 equals 0. That thing can fuck off. What time is it? I have about half an hour left, so I'll probably just going to finish up this calculation here. Then I'm going to turn the stream off and I'm going to do all the other stuff that I need to do. And then I'm going to get ready, right? Because I don't want to... Right, I'd rather do a tiny bit less math than miss my train, right? So that's the goal. So here we can do this with PQ. I knew that Tony did it some other way. Formula. I don't actually know what the formula looks like, but I know what the answer looks like. It's lambda equals this thing here divided by 2, which is 1/4, plus minus so this thing here positive, which is 1/2. I'm actually going to write it as 2. Wait, let's see here. So we want this in be 16, right? Because that thing will be 16. So it is this times 8. So 8 divided by 16. I should actually write it like this. I just like, I want to minimize the possibility that I fuck this up at any point in my life. So I'm just gonna be super proper this one time. This thing, and then here is a minus here. So this is 1/4 plus minus the square root in this case of 9/16, which is 1/4 plus minus 3 divided by 4, lambda 1 is equal to 1, and lambda 2 is equals to minus 2/4, which is minus 1/2. In order for a method to be zero stable, we need the following root condition to be met. Where each root lambda I has to be within the unit circle and any root on the rim has to have multiplicity equal to 1. So root has to be less than or equal to 1. And if lambda I equals to 1, then multiplicity equals, I don't know if there's like a way of writing multiplicity equals 1 there in a more mathy way. I don't know. Maybe there is. Likely. Yeah. The root conditions are met. Method is zero stable. Bam! There we go, chat. This is the first boy. It is a lot of math, and I got a little stuck in the beginning, but we got there in the end. That's an easy 5-pointer. This is a very standard equation. We're going to be doing these types of questions many times during these weeks. Maybe I'll stream in the evening. I don't think I will once I get to my parents' place today, honestly. But we'll see. Yeah, so thanks to you guys for watching. I'll see you guys around, and yeah, I probably won't bring my microphone to my parents' place, so it'll just have to be quiet streams. I think that like these headphones, when they're in Bluetooth mode, like I can play audio from them, which I'm not doing right now anyway. Like it's not a huge loss. But yeah, we'll see. We'll see. But thank you guys for watching. It's been a pleasure, and I will see you guys around. This has been a nice hour. Thank you.